In the second lecture, we are about to learn common practice in shell scripting. We will study a short history of common shell interpreters. At the end of this lesson, you will be able to recognize the main parts of a general script structure, how to specify the name of the shell to be the interpreter of your script. We will create and execute simple shell scripts. You will know how to comment your scripts, how to properly end up a script. We'll try to use existing resources in order to get coding experience. We'll cover some elementary notions regarding the preparation of a script, particularly the correct planning of a programming code. And we'll end with the code portability issues when moving from one shell to another. During the early years of computing, the Unix operation interfaces have had a rapid development. The reference modern command line interface for such systems is the Bourne shell. Its name derives from its inventor's name, Stephen Bourne. In 1971, he officially became the creator of the first truly modern interface for a Unix system. The syntax of the Bourne shell programming language resembles that of an old and respectable language, the ALGOL. Although it initially was meant to serve as an interactive command interpreter, the Bourne shell was also intended as a script language interpreter and contained most of the features that are commonly considered to produce structured programs. A modest notice, the C programming language itself was written with the directive #define to look like ALGOL. A few years later, in 1979, Bill Joy from the Berkeley University of California came up with his own version of command line interpreter, which became known as the C shell. It contains most features of the Bourne shell plus many new ones, better suited for an interactive operating mode than for batch processing. The C shell resembles the standardized C programming language. As a footnote here, the C language itself has some inherited syntax from the old good ALGOL. Apart from its interactive usage readiness, C shell also brought some new and very useful features, like the command history, the compact code block facility, also known as the here document functionality, and built-in arithmetic calculation tools. Overall, its new features allowed an easier and faster operating mode. The Corn shell was created in the mid-80s. Commonly considered a superset of the Bourne shell, the Corn interpreter displays some of the most useful features of its successor, the C shell. Major differences between Corn shell and the traditional Bourne shell includes the following. The processing jobs control, command aliasing, command history, all of them deriving from the C shell, associative arrays, and built-in floating point arithmetic operations. Ultimately, the Corn shell was used as the basis for the POSIX standard. The latest was developed by combined effort of an AT&T, OSF, and Hewlett-Packard team of experts in order to provide what's not considered an Unix platform's unified operating tool, the POSIX conformant shell environment. The POSIX shell pretty much resembles to the Corn shell, but is actually newer and better. Given a rather generic overall acceptance in the world of Unix operators and admins, POSIX has become the default shell in HP Unix systems since 1992. In the real world, you will discover several shell interpreters. All you need to know when interactively working is that your current shell is the one the system's administrator actually assigned to your current user's operating profile. Besides those we have approached so far, there are some other shell interpreters. You hereby can see a comparative list of features of the most commonly used. Just so you know, there is the not so commonly known key shell, which is an operational interactive extension of the POSIX environment and is centered around a hierarchical softkey menu. It is also fitted with a performant context-sensitive help utility to aid those users who do not wish to memorize some fancy Unix commands. The key shell is also developed by HP and AT&T. In the same note, we also use the bash and the T shell. These are enhanced versions of the Bourne shell and C shell respectively. In contrast with their general design philosophy, the Korn and POSIX interpreters can handle some custom secured operating sessions, which are meant to implement restriction on particular user profiles. That can be quite useful for administrators who manage multiple interactive sessions of currently working users. Anyway, these and a lot of other interesting features are available for study in the Man Pages consulting system. Usually, a shell script will be interpreted at the runtime using the same shell as the interactively driven shell of the user that executes it, if you remember the fork exec procedure. This can prove to be a distinct disadvantage, especially when you would like several other users belonging to different groups to be able to execute a script you created. The best way to ensure that your script is correctly interpreted using the very intended tool is to specify the shell for which it is written. For that, we can make use of the first line of the code specification, the shebang directive. When the exec system call is invoked, it will check right away the first 2 bytes of your script for a special instruction, the pound exclamation mark call. This is actually pointing on the same line to the interpreter name. These two especially designed symbols are known in English phonetic convention as sharp and bang, hence the shebang denomination. What you actually contemplating on your screen are the full path qualifiers for the mostly used shell interpreters on HP machines. In fact, the first 2 of them effectively point to the POSIX shell for further command processing. Considering the example from the previous lesson, the assumption we hereby have a functional script is still correct, given the fact that we could in fact get the right output because at the time we were currently operating within a POSIX conformant context. Had we intended to write a perfectly well-defined shell script, we should have used the proper shebang directive. The program comments. A commentary can be added anywhere in the shell script, and any line of code which the shell is expected to ignore is always preceded by the pound symbol. Comments are very useful to both the initial code creator, the further developers who take over, and the end users as well. The comments help document the programmer's ideas about how the program works or how it is supposed to be used. It is a good idea to provide such information whenever the syntax being used is not intuitive or is complex. No matter what a pound symbol appears, the following text is considered a comment and won't be interpreted by the shell. In some particular instances, the pound character will be explicitly referred to between ticks or quotes, or by having it escaped with a backslash. The script format you are seeing on your screen reflects the most widely used template for shell script code. Most good scripts indicate the interpreter, have some brief comments about the script right at the beginning, and then dwells upon the effectively executable commands. The exit command at the end is optional most of the times, but it is a good idea to include it. There are some cases when the script may be called from an application and the exit may be expected in order to correctly end it up. An example of this would be in using administrative or backup scripts with the HP OpenView OmniBack product. If the exit is not provided, the caller may hang waiting for it. If you are unsure about whether to use the exit statement or not, the general rule is to use it. Specifically, here is a sample shell script with a format that complies to the conventions exposed in the previous slide. So we have the shebang token. We have the comment block at the beginning of the script with general references to the content and purpose of this program. And only then the rest of the script follows, ending up properly with an exit command. Most of the utility programs supplied with HP Unix are compiled, that is, binary programs. Most of the administrative controls, however, are managed using shell scripts. These scripts can be useful to the non-administrator programmer as working examples of the POSIX shell languages. Some programmers may find it useful to look at the programs that others have written to help them learn some of the language constructs. For instance, the /bin directories listed on the slide are rich resources of example programs. Generically speaking, here's how they work. When the system boots up, daemon processes are started by a series of shell scripts in special locations, the runtime directories. These shell scripts are used to display a list of actions that is only visible at boot time. The other way around, when the system shuts down, the same scripts are invoked, but this time to terminate the daemon processes. Once again, a list of actions is displayed by these scripts when the system is shut down. The main idea here is to consistently accumulate experience by closely examining these coding methods and the output messages formats. Some utility programs are in fact scripts. So is, for instance, the umask command. You may eventually have a good look to other files corresponding to other commands in order to identify shell script code by using the file utility. Some shell scripts of the same class as these ones do not have execute permissions. They are invoked using special shell syntax. They are effectively started up within another running script. This kind of codes, the boot time scripts, can be easily identified. If you use the command on the screen, you'll be able to see an entire list of such programs used for starting up a genuine HP machine. A shell script is a program. By definition, such a program is a list of programmed processes running in the appropriate conditions. In its simplest state, a shell script could contain just one command line. However, it is more common to have shell scripts that consist of several command lines that must be properly managed in order to be launched safely. This kind of management involves the use of logical condition testing and the use of the correct variable types, flow control handlers, or combinations of the two. As an alternative to online editing and testing scripts on a real machine, we suggest planning and rather writing the code in advance in a separate editor, eventually one backed up with a code version management. The offline assessment of the program instructions can arguably be the best action to take and will help you understand the structured logic as well as other typical aspects for code programming, such as: are there special variables needed? Will some user input be required? What kind of output messages is the script supposed to display? Will any user-defined shell functions be called by our program? Is there any logical testing involved? Will you use linear processing jobs, or you will implement code iterations? In short, you will be dealing a lot less issues during the testing phase, and the overall testing time will be significantly lesser if you consider careful planning of your code. As a suggestion, once the script components, that is the groups of commands logically related or interconnected, so once they have been identified in the planning stage, you should reorganize them into an optimized logical structure. If you ever use pseudo-languages to write your code, each of them can subsequently be converted into Unix-specific programming syntax, the shell scripting syntax. By reducing the complexity from an entire script to a single component, you reduce the risk of writing non-functional code. Always take small steps of a reasonable complexity. Therefore, in the preparation stage, you should always try to simplify the operation of the script as much as possible. Once a working script has been produced, you can add further complexity to it. Sometimes there are issues when porting a shell script. Certain forms of syntax are standard within the Bourne, Korn, or POSIX shells. Other forms of syntax are specific to one type of shell. If your scripts are to be written and executed on a number of Unix platforms, issues of portability must be addressed. You may find that some programmers still use the Bourne shell syntax even when specifying the POSIX shell as the interpreter. This might just confuse a beginner. It is therefore useful to test the POSIX-specific shell program syntax if you are running a migrated shell script copied from a non-POSIX-based system by the default current shell. What you need to understand in the end is that in general the proportion of functional shell scripting code to be ported to multiple platforms is high enough. Nevertheless, if you ever want to test a script written on a non-POSIX system on your POSIX compliant machine, you need to contemplate a few changes that might as well be necessary to adapt it.